Yeah, acceptance. I wasn't really accepted as a kid. You know, I was a little bit different from everybody else, and maybe that caused my lack of acceptance. I'm right in the middle of this. Do you have to make this noise right this? Exceptions? What do I know about exceptions?
Errors, whether at compile time or execution time, are part and parcel of the programming experience. Inevitably, you're going to make some syntactical error that's going to cause your program not to compile, and every so often you will create a piece of software that at execution time it crashes badly. The overriding concept in handling errors is to, number one, prevent the user from seeing something that they don't need to see, and number two, to grab a hold of an error as soon as you can or prevent that error from happening so that you don't cause a larger system crash when your piece of software happens to run into an error. Now, I want to demonstrate an error here and show what the user is going to see, or better yet, what we want to prevent the user from seeing. So I've got a little bit of Java code here. It sets up a loop to ask for a certain piece of information. This is something you'll do a lot. We're going to show a menu, and then we're going to choose from that menu. So when we execute this, it is asking you to pick from the choice. Now, because it is a poorly designed menu, the user doesn't know whether they are to hit the numerals on the left or select the letter from within the brackets here. So I'm going to take a chance that the numerals are correct. We'll hit number 3, and that is correct. So by hitting 3, I have caused the situation of not equal 3 to fire, and it has allowed me to drop out of the do while loop. But let's look at a different situation. Because I have poorly constructed this menu, I might be tempted to type Q to exit out. Oh, bad news. Now, because it is not an integer, I have caused what is known in Java as an exception. I have caused an error because next integer down here didn't know what to do with the character input that I gave it. And so when we execute that program and that particular instruction is processed and it receives this letter Q, it crashes the program. Now what it shows is I have in the scanner object fired a throw error because of this, because of this, because of this, and it's telling me I've created this error at this point down here, and so on. So I know where the error is caused, and I know what the error is, and so now I can go about addressing this. You do not want your user, on the other hand, to engage anything like this, because this is going to cause them to curl up in a ball and cry. So what is an exception? In Java, an exception is more than simply a state of the software having a problem. It is an actual object that contains a description, a path, a code, everything you need to know about what caused the problem, where the problem was generated, what the conditions were that caused the problem. All of these things are contained inside of that object. And so Java provides tools that you can use to not only trap those objects, but then identify the object and handle it so that your program is either restored gracefully, or if your choice is to end it, to end gracefully without all the ugliness that we just saw in the last bit. Now this second version of the program adds some additional code to it. We still have the same process loop up here. It's going to read the menu and process it. And I've kicked in another method here called showRunner that would handle the menu choices. But what we're really interested in is down here in show menu. The main components of the exception handling facility in Java are the try and catch blocks. Try is a block that surrounds the statements in which you anticipate an error might possibly occur. So we know that somewhere between displaying the menu and gathering input from the user, that a potential error can occur, and that is that we might get an incorrect type of input, and that's something that we want to handle. Now, there is a reason that I have surrounded all of the instructions for displaying the menu, and we'll demonstrate that in just a second. So what that try block says, if an error occurs, if an exception occurs inside of the code in this block, I want you to do something with it. And that doing is a process called throwing. Inside the try block, if an error occurs, an exception is going to be thrown. Now, that thrown exception can veer off into the ether. It can be totally ignored. Or you can catch that object that is thrown. You can catch or trap that exception object and do something with it. So in the case of the code that we're looking at, we have a try block that surrounds the menu, and here's the source of our error. So we anticipate that there might be a problem with next integer. We are going to, if an error occurs, throw the exception from here down and attempt to catch it here. Now, the catch block is identified as to what type of an object to look for, and we'll see that this can be expanded a little later in this video. But for right now, we're looking for a specific type of an exception, and that is an input mismatch exception. So we instantiate an object of mismatch exception. We're going to call that simply E, and then we're going to handle it. So within this catch block, we're going to clear the stream. That's what input next is doing, because when the exception occurs here, it realizes that there's no integer being input if that's the error source. And so of course that never gets assigned over to here, which means that that character is still in the input stream. So all we're doing here is cleaning out the input stream. Then I'm going to provide an error message, give myself a blank line, and what's going to happen is this is going to exit, and it's going to reprint or redisplay my code. Alright, so here's my error. So if I hit 2, nothing's going to happen. It's simply going to cycle around. But if I hit D, now we're going to generate the exception. Now watch the difference here. Instead of that long crash trace report that was displayed on the screen, we have caught the exception and handled it very gracefully by simply displaying you have given me an incorrect message. I have cycled back here, and now I can type 2 and nothing happens. We go on about our business, type 3, and exit out of the report. So try and catch go hand in hand. You can't have a try without a catch. Your compiler will bark about that. In that preceding piece of code, we had one possible exception situation that we had to deal with, and that was that the user would type something other than an integer choice at the keyboard, and would cause us a problem. In a lot of instances, though, we have more than one potential exception, and this little bit of code that we're looking at right now has 2 potential exceptions. Number one, the one that we are familiar with, is the possibility that they're going to give us something other than an integer, and that can cause a system crash. The other thing is that we're going to perhaps attempt to divide by 0 or something and cause a further crash. So let's execute this program as it's written and see what kind of problems we can get into. So if we go 10 and 2, we know that's going to execute just fine. So if we run it and we give us a 10, or we give us a Q0, obviously invalid input. So we run this again. The other kind of invalid input we might get is 10.2. We know that's a problem. Okay, so we need to handle that. And there is one more possible exception. We go 10 divided by 0, and that is also a problem. So we want to take advantage of Java's exception handling system. And one of the nice things about the object-oriented nature of the language, it gives us the ability to handle multiple types of exceptions based upon the type of object that is received in the catch block. We do this by building multiple catch blocks. By modifying the code, and number one, we go and encircle our potential problem situation here with a try block. So it's going to be examining all of these actions here to see if an exception is thrown. If an exception is thrown, I have not one, but two catch blocks looking for two specific potential problems. Either an input problem, where the user gives me a character, or they give me a double, or anything of that nature. That's going to be trapped by this. If the exception is not an input mismatch exception object, this is ignored from this block marker to this block marker. It simply falls down to be caught by this handler. So the catch arithmetic exception, if that's the issue, then it handles it here. So we can stack these up as deep as we need to go to handle all of the potential exceptions that could occur within the block of code there, within the try block. So let's execute this. We know that 10 divided by 3 will give us a good answer. Okay, so now let's try to generate some problems. All right, so 10, and we'll say 2.2. Now that tells us it's not an integer, and the program is leaving. Because I haven't caused any, I haven't given any code to go back and loop again to correct the answer. We're simply terminating, and you can see that that is the instruction right here. So I simply send the instruction, clear the stream, and get out. Okay, and we'll come back to this instruction in just a sec. Okay, so let's execute this again. Put a Q there. Again, not an integer, kicked us out. Life is good. Now let's try the divide by 0. So if we give an invalid type of division, 5 divided by 0, normally that would cause a system crash, but we threw the object, we caught the object, and we have told the user what the problem is. Now we have gone above and beyond to try to report some information to the user. This object that is thrown, this exception object, contains a world of data within the object. It contains the location of the problem, the nature of the problem, the code of the problem. And so I've thrown a couple of the internal methods into the code here. So when we execute, we catch a mismatch exception. We're simply going to explain what the error is. On the other hand, when we have the arithmetic exception, the divide by 0 problem, we're going to print out a stack trace that shows us where the object is, or where the exception occurred. Now, of course, you can combine all of these if you want a full error report, but let's look at what we didn't look at the first time. All right, so we give a Q, so mismatch, and we see that this tells me that it generated this type of an object. So at least I know what the object was that was thrown. Doesn't do me a lot of good, but it's helpful to debug the program. Now, on the second one, let's do the divide by 0. That's not going to work. 10 divided by 0. Now we get a little bit more information. We get the type of error, divide by 0, and it tells us where the error occurred. So we trace that back to 22. We see 1, 2, 3, 22. There it is. That's where our error occurred. So obviously in this expression, the exception was generated, it was thrown, it was caught, it was handled. The last piece of the Java exception handling facility is the optional finally block. Now what the finally block does is it acts like a fail-safe or a final set of instructions, particularly useful if you are going to terminate your code. If the error that has been generated is essentially fatal, you're going to often add a finally block to close down streams with the operating system, close down database files, close open files, close down network connect, do the kinds of housekeeping that are necessary so that the error that has been generated in your program doesn't propagate further into the OS or into the network OS. And so we've added a finally block to the same code that we've been trapping. So what will happen is if an exception is thrown in the try block, and it will be caught here or essentially ignored, what will happen is the processing will either process through the catch block or be ignored, but it will go to the finally block before exiting. And so whatever we place in here, close files, close down network streams, whatever it might be, these will be handled before the termination. So when we execute, we won't be surprised to see what comes out in the, let's do a divide by 0. So 10 divided by 0 is going to, of course, terminate. That's the error that the error message that we wrote. We still have the trace in there telling us where the error occurred. And down here we see the final line cleanup will go here because the finally block fired, and whatever we placed in there, closed down the files we're working with, etc., that'll get processed at that point. So you have 3 components, 2 which are required, the try and the catch, and then the finally block, which is an optional component, but in a lot of instances you're going to find yourself using it. Alright, in this pro tip, I want to show you something that you're going to be tempted to do, but you don't want to do. Now, the number of classes in the Java exception handling group is extensive. But like any good system of inheritance, it goes from general to more specific. The superclass for all the exceptions is called, wait for it, exception. And that is, in its design, the most general exception that can be generated. What that means is that everything can fall into that class. So anything that happens, if your program sneezes, it can be thrown through a simple exception object. Ideally, you want to go from more specific to less specific. And so in this code that we're looking at here, you see that I have added a 3rd catch block, and it's simply called exception. So it is a non-specific exception catch. Now that means that if an error is generated in our try block and an exception is thrown, if it is not an input mismatch, if it is not an arithmetic problem, then it will be caught by exception. An exception will catch everything else that happens. If we have a specific error, then it won't be a problem at all. So when we execute this will do the same thing that it did before. So we'll catch the divide by 0, and it went to the specific arithmetic problem. So the arithmetic catch block handled it, reported the divide by 0, and took care of it. Now if, let's just comment this out. if we generate an error in the try block, an exception that is not caught by one of the specific errors, then it would fall through to the general exception class. So by commenting out the arithmetic problem, we can emulate what would happen. So we'll do divide by 0, 3 divided by 0. Now, instead of giving us the report that tells us exactly what the problem was, we get this general message that every computer user has probably seen. Unknown error, you're on your own. Now, what you might be tempted to do is say, hey, let's uncomment this. Why am I working so hard? Why don't I take this catch block and move it to the top? We should have a little quiz right here. The one thing you don't want to do is to try to catch from general to more specific. First of all, your compiler is going to bark. You're seeing errors over here that by the time it got to this catch block that the general block has trying to catch it. So this won't even compile. You're going to generate an error, and you see that that's a problem there. But in general terms, in programming and design terms, you want to use the most specific, or catch the most specific object first before trying to handle the less specific or the most general object.